My parrot is missing. I know. Polly, gone. Speaking of polygons, have you ever seen this equation before? The sum of interior angles of a polygon equals n-2 times by 180 degrees. If you want to easily understand where this formula comes from, and hence why it works, then watch on. By the end of this video, you'll be able to effortlessly reproduce this formula and use it whenever you need to. If you're just here for the formula, copy it down now, revise it, and watch one of our other videos. For those of you sticking around, in this video, firstly, you'll learn why the angles in a triangle add up to 180 degrees, and secondly, you'll see that all other polygons can simply be broken down into triangles, which then leads us to creating the formula. So let's begin. Before we look at a triangle, let's look at a dot, like at the centre of a clock. If we do one full rotation around this dot, we trace out 360 degrees. Hence, if we split this in two with a straight horizontal line, we have 180 degrees on both sides. So, angles that combine to make a straight line must add up to 180 degrees, such as angles A, B, and C below. Let's add another horizontal line to our diagram. If we continue the line of angle A, you can see that we make a Z shape with the line below. And because the horizontal lines are parallel, we know that this angle must be the same as this one, A. Now, if we do the same thing again with angle C, we get a backward Z, but again, because the horizontal lines are parallel, we can see that this angle must be the same as C. You can see we have now made a triangle, and its three angles are A plus B plus C. And we know from earlier that A plus B plus C is 180 degrees. So there we go. We've proved, starting from a dot, that the angles inside a triangle add up to 180 degrees. You probably knew that already, but now you know why. Now, let's look at a four-sided shape, also known as a quadrilateral. There are lots of different types, which we cover in another video, but here we're interested in the sum of the angles inside any quadrilateral. What do they add up to, and how do we even begin? The simple answer is to break the shapes down into triangles. Put your pen on one of the corners. As a quick aside, the fancy pants word for a corner is a vertex, and if we have more than one vertex, the plural word is vertices. Right, back to our shapes. With your pen on one of the corners, draw a line to the other corner that isn't a next door neighbour. You can try this starting at any vertex, one will definitely work. I will choose random vertices and do this for all the other quadrilaterals we have. There we go. You'll see that all of these shapes are made up of two triangles. You'll also see that the interior angles of the quadrilaterals are simply the sum of the angles of the two triangles. We know the sum of the angles of one triangle is 180 degrees. So the sum for a quadrilateral is two triangles, 2 times 180, which is 360 degrees. Let's make a table of our results. A triangle has three sides, it is made up of one triangle, and the sum of its angles is 180 degrees. A quadrilateral has four sides. We can split it into two triangles, and the sum of its angles is 360 degrees. Great. Let's quickly do the same treatment for a five-sided polygon, which is known as a pentagon. Again, we can choose a vertex and draw lines to other vertices that aren't immediately next door. And we can see that this breaks pentagons down into three triangles. The sum of the angles of the pentagon is the sum of the angles of these three triangles, which is 3 times 180, and that equals 540 degrees. We'll add this to our table, where we can now see a pattern. Each time we increase the number of sides by 1, the number of triangles increases by 1. But why is this? Well, let's take any shape, and just zoom in on one side of it. To increase the number of sides on the shape by 1, we could convert this single side into 2 sides. We can do this by just pretending it's a piece of elastic, grabbing it at any point and pulling out a new vertex. This means our single side has now become 2 sides, an increase of 1. In doing this, you can also see that we've added in a new area in the shape of a triangle, traced out here. Hence, we have increased the number of triangles in the overall shape by 1, no matter what shape we started off with. So let's look back at our table and see how this translates into a formula for the sum of interior angles. We know that the sum of angles is the number of triangles times by 180 degrees. But we can also see the number of triangles is always equal to the number of sides minus 2. So let's use that in our formula. And to make it neater, let's just use the letter n to denote the number of sides in our polygon. And there we have it, our fancy formula of n minus 2 times 180 being the sum of the interior angles. I hope you feel more confident now you know where this comes from, and that you could actually construct this formula yourself if you really needed to. And why not give this video a like if you found it useful? As well as the formula itself, breaking shapes down into triangles is a great skill to have when it comes to geometry questions, which you will see if you check out the other videos on our playlist. So, go and choose another video now, and I'll see you in that one. Until then, I'll see thee.